Hello, everyone. My name is Eduardo. I'm coming from Portugal. And today, I'm a DevOps coach in Atixis, and also I'm a co-founder of DevOps Porto user group. And today, I'm talking about deployment pipeline for databases. These are the two themes that I prefer: pipeline and databases. So that is our agenda, the challenges, the stages, and the scenarios I've been working on so far, and some takeaways. Everyone knows this gentleman, Martin Fowler. Pipeline is all about to see the flow, since the moment we make a change and the moment it reached production. So sometimes it's really hard to sell the idea that pipeline is it's important as the software. So if you was a car manufacturer, your fabric is almost important than your car, because great fabric constructs great cars. So it's really hard to keep making great cars without a great factory. So that's the importance of the pipeline. So what about database on this pipeline? So I identified, or I divided in 3 stages. The first one, it's where we describe the change. The second one, it's the change validation stage, when you make sure we don't break what's been built so far. And then we make real that change on our production or even other environments. So this is the 3 stages, very common. And when I started to work, this is true for software, for application side. So, but the database seems was not included for different reasons. So, and I started to wonder, why is database different? Why you have so special? So everyone knows that guy. Does anyone want to answer why it's so special? Why database? What the key ingredient that makes database special? Sorry? Vendor locking. No. Could be. Or we can create our own database, but it's still locking. Because? No build process. So no. You will deploy you never deploy the full thing. No, let me help you. Data. You have to preserve data before, during, and after the deploy. If you want to make a rollback from your database, make sure it works. Because you can put bugs on production. You'll make your customer annoyed, yeah? But if you lose data, not only your customer makes angry, but you lose money and reputation. That is very hard to get, reputation. So the database is not stateless, right? Like an application. So that's why it's so special. That's the main reason that we treat different database from the application. So I see two approaches. One, we treat it differently. We have a separate process or even a pipeline for the database. And the other approach is, let's the DBA handles that problem. So we don't care. We give them all power and all responsibility to database. So that's really hard to talk with the database administrator sometimes. So about this, about the manual work. So it's like an artist for the database changes, right? This is the most dangerous and the most expensive kind of work in an organization, because we are just doing manually. And since you are doing manually, it's really hard to start a process when we automate. So it's really hard to, even you get all the application automated, if you have a database, manually, you have to wait. Database will continue to give you headaches. And since we deliver all the power to the database, to the DBA, we have a lot of fear of making change to the database, right? Because it seems very magic, dark magic. So who didn't have to wait for a database change? So I need a new field on my form login. I have to wait that column be available on database first. Okay? So it's really hard. It's really easy to database become a bottleneck. So how we solve this? Automation. Why? Because with automation, we can we can keep control of things, of the changes. And if you get control over the change, we gain speed. You cannot gain speed without control. And we start to be reliable. We start to repeat, we start like practicing, right? And as a bonus, we reduce the human intervention in the release process. So that's one of the aspects I like is we go from do it manually, and every time we do manually, we have to relearn, remember, and do it, and probably add a different way to we done in the last week, and forget and just improve. It's a script. I just look to the script, I improve the script if I need, and just forget it again, and come back to the script, and so on. So the purpose of this is we don't need to be afraid from database change. Why? Because it's just a piece of code. You can put any change on the database on SQL script. And this gives us traceability. This is one of the most important aspects. We need to know what changed, when was changed, and who changed it. And with these three, I can even go and see why it changes. Because one of the questions that every database administrator makes, why I need to change. Nobody likes to change, especially on ops. We don't like changes. So if I don't like changes, I want to control them. SQL has a documentation, okay? I open a script, I see the change, I already know what's the change. And we can share with this with developers, so we already enable a common language, so we are already breaking silos. And in the meanwhile, we are just enforcing the standards. So how we describe a change on a database? We have two approaches. One is a state-based solution, and the other one is the migrations-based solution. In one way, in the first one, on the state, I have two states, the present one and the desired one. Okay, so we have a generator that compares the two states and generates a script, and that's it. Okay, it builds that Delta script. In the migrations, we have someone that writes that change. So in the state, I have a declarative approach. In the migration, I have an imperative approach. You will need both. This is already a hard discussion, which one is better. I prefer the migrations on the daily work. What I mean is, I prefer that developers write the change. That way, I look to the script, I know already, I see exactly what he wants to change, okay? And this way, not even allows me that, but also I can learn or teach how to write good scripts, okay? That means we can close the database and developer. Because one thing is to process data. Developer really knows that, but another thing is to store data. And database know how to do that. So that is very important to keep them together. And we have two tools that you can Flyway and from Redgate SQL Source Control. Okay? I think that image describes the main difference between them. Okay? So during this path, so I started to work on a telecom company where all the business logic was on database. So store procedures, functions, everything was in database. Now in Natixis, I'm working, it's a bank, so I have kind of the same scenario. So the key takeaway is keep it small. So I created a rule in that time that was one script can only have one operation type, a create, an update, or an insert, for one object. So this is a rule that worked for my context, so you have to make your rules. But what we saw that happened, that it allows us to manage better the merge conflicts, because everyone shares the database, right? Do we have all your applications have its own database? Normally, you have a database that serves a lot of applications, normally. And since you are cutting change to small pieces, it's funny, but you start to see patterns, how the database changes. It's like you, in Matrix, you start to see the way the database changes, because your rules, the business rules, will not change very much. Since the moment you see the business rule, you will not change very much. And since you have all no scripts, so I have a create table, insert table, and as I look to the list of the scripts, I keep the history of that object on the database. I can see when it was created, when it was inserted, when it was updated. So that is just a guideline. It's not a rule, but it's a guideline. And okay, I have my script, my database change, and now I need to put it on the build. I need to build an installation pack. First, I need to test it. So we can do unit testing or integration test, and we can use tools like T-SQL-T that allow us to make unit testing. And once again, small batches, you are decreasing the risk. Okay? So, for example, this allows, that's why in this moment, it's one of the moments I think the state approach can work. Because you want to create a test environment, a test database on the fly, and if you have, let's say, 10,000 scripts, you will have to wait. But if you do this state to this state, it's much faster. Or you can always rebase the database, okay? They have a lot of, or can use Docker to set up a test database and drop after the test. So what we have to consider on this moment, we can use Jenkins, via TFS, whatever. What should be tested? For example, what makes sense to test should be like business rules, like startup procedure or functions. We can test tables, or we can check if a table exists or not, a column or not. When should be tested? Before deployment, during deployment, after deployment. We have to think on this. And one of these, can the application help on this? What this means? It means I work in two opposite scenarios. Where I have everything on the database. This clear, I have to do that effort on the database side. But if the application, the business rules are on the side of the application can do that work for the database. I don't need to go. In other words, if the database it's only have tables, with no store procedure, no functions, that means all the business rules will be on the application side. So application can test it. So next step is to deliver that change. What we have to think? We have to think in downtime, in time to recover if something goes wrong, and the affected applications. So that's why in a microservice approach, the ideal world will be one application, one database. So if I need to stop a database, I just affect one. Okay, we are reducing the impact surface. And once again, it's keep it short, keep it small, keep it risks down. And what about if something goes wrong? What can we do? First, I hope you made backups. Okay? Daily backups, backups before deploy, but sometimes it's not possible. If you have to make 2 terabytes backup, you have to wait, what? 1 hour, 2 hours to make a deploy, okay? The backup approach, it's always the safer approach. If you keep this database smaller, if you think on a database as a microservice, it can work, okay? The other approach is using scripts. This, you can use rollback scripts or roll forward scripts, okay? So if you're creating a table, you can write bottom of that script, you can write another piece of code saying, if I create this table, I want to drop this table. But if you make the other way around, if I want to drop a table and then recreate, you will lose all the data. Okay? And to make rollback scripts, what happens to the tools, it's always leave to you the responsibility of creating the rollback script. Okay? They say what? They say, okay, we support rollback. Yes, but you have to write it. So that means if something goes wrong, it was your fault. Okay? For me, it's really easier. It's easier to think always roll forward. So if I make a mistake, the next step, it will be the correction of that mistake. Okay? It's easier to think from left to right. So if you, in the moment you are writing a script, if you have to think on what goes wrong, if the change is so much complex, you can lose, and then you can reach the point you have to correct the rollback. You see what I mean? It can be highly complex. Okay, so now it's the scenarios I've been through. So I started in the context, so I have only application have the pipeline. And I start to discuss with a developer friend of mine, so how can we solve the database problem? Because we are doing fixes on the Sunday afternoon, and you have to go there to production and make some change, right? So how can we solve this? So the first iteration, okay, let's start the pipeline. So the database is just a script, so let's do it. Let's create a pipeline just for the database. So you keep the application in one pipeline and database in the other in another pipeline. So that means everything is independent. Source control is independent, build is independent, and the delivery is independent. So that means we have to talk with the database team, with the database, using Skype, mail, Slack, texting, calling, and email should never be used for delivering process, okay? And we suck, our worst skill is communication. So we try to avoid the communication because we are bad on that. That's why I'm speaking, okay? So the next step was, okay, how can we improve this? We have to reduce the synchronization between the teams. Okay, let's put a touch point on the continuous delivered stage. So we keep the independent repos. We build it independently, but we deliver together. So, for example, I first deliver database. If I have success, then I deliver the application. But with this approach, we didn't have sure if that application has the correct version of the database, because we are deploying the latest one. Okay, we don't control the pipeline. We only control the moment they touch together. So if the application is version 2 and it needs version 3 on the database, and someone already triggers the version 4 of the database, then now you have version 4 on the database. It's not the correct version, okay? And this was a really fast stage. So, okay, let's put the build together or related. So, for example, if I build my database and if it fails, I don't need to start my application build. So we just keep the different code repos and we connect the other two stages, okay? This kind of worked, but we rapidly evolved to this. put all together. So in the same repo, we had the code for our C# classes. We had our scripts. We just put a folder with the scripts. They are versioned, right? On time, I prefer timestamp because give us the time context. And we build it together and we deploy it together. So we end up with only one version. That version is for app and database. And in the slide it says no need for synchronization, but it's not entirely true because we do the synchronization where? On the repo, on the commit moment. We put developers and database making peer review. So that if we could put someone on develop and database making validating the scripts, if it's okay, naming convention and so on, it's just okay, go ahead. And by doing this, we bring these two worlds together. So database didn't start to learn how to process data, and the developers start to see how data should be stored. Okay, this is my kind of definition of the pipeline. It's not the only tooling, but also represents the cultural way you deliver change to the production. And the last line is somehow provoking. So if you show me your pipeline, I will tell how the way you work somehow. Okay. Okay. What DevOps? Where DevOps comes in? So it started with the will of improving together. So with the ops or a database and the developer talking with each other, we increase the flow visibility. Okay, we break silos. So how you do a change? How do you change? We increase the feedback. If anything breaks on the database, all the team will receive that alert. We'll see that, and we'll work together to solve that problem. Not only app or not only database. And we increase the knowledge base. So if I need to make a change in the database and the database administrator is not there, okay, do I have to wait? Or can I do it myself? Because I already know it. I don't have that fear because we make it process reliable. Okay, these were the books that was along my path. The first one kind of represents the first stage of describing a change. The second one, the continuous integration and the continuous delivery, and the other tools. So this is a mix between the tooling and the engineering and the culture side. Okay? And that's it. I hope you like it. If you have any question, please.